question about normal distribution. Today I'm going to teach you how to solve this. The question asks us to sketch a diagram of the normal distribution and shade the region representing the probability that the speed of a vehicle is between 60 and 70. From the information, we can find that the mean of the normal distribution is 67 kilometers per hour, and standard deviation is 3.4. The diagram of the normal distribution is shaped like a bell curve. It is 50% from this side and 50% from that side. It is always symmetrical. The middle of the bell curve is the mean of the normal distribution. And these sections that I drew represent one standard deviation. So the two sections are two standard deviations. Vice versa here, these sections are minus 2 standard deviation from the mean. So then let's go back to the question. We drew the diagram and we have to represent the probability that the speed of the vehicle is between 60 and 70. So 2 standard deviation from the mean is 60.2. We approximately find where 60 is, and then we mark that. And then 1 standard deviation from the mean is 70.4. We approximately find 70 and then mark that. Then we shade this area. That's it. Question done. Moving on to the second question. Find the probability that the speed of this vehicle is more than 60 kilometers. So we could use the normal distribution curve, but it would be easier to use the GDC. What we do is we go on menu, 5, distributions, which is 5.2, and normal CDF. We get this. So the question says, find the more than 60 kilometers per hour. So 60 is the minimum value. It is the lower bound of the normal distribution curve. That's why there is no upper bound. See, more than 60 kilometers per hour. So that is why the upper bound will be 9 to the power of 10, 9. This is the scientific notation of, well, let's say infinity, or yeah. Then we delete this part and write, what does it say? 60 kilometers. The mean of the normal distribution bell is 67. And the standard deviation is 3.4. Enter. This is the answer, 0.980244. That is the probability of the speed of the vehicle being more than 60. That is the number of the probability. If this was in percentage, it would be 98.0244. And you have to remember that the probability under this bell curve is always equal to 1. And the percentage under this bell curve is always equal to 100. 50 that way, 50 this way, as I said at the beginning. So this question done. Now let's look at question 3. It says, find the probability that the speed of this vehicle is between 60 and 70 kilometers. So we are given the minimum and the maximum value over here. This is less than 70 kilometers. So this is the maximum value, and this is between. That means that we're trying to find the number between a possible boundary. That means, well, yeah, minimum, maximum. What we do is we go back to probability, distributions, and normal CDF. Lower bound. Are we given the lower bound? Yes. The The lower bound is 60. The upper bound is 70. So the mean is 67. We enter that all here, and 3.4, enter, there you go. That is the probability of it being between 60 and 70. That is either 79% or 0.791452 of probability. Okay, a different question. It is found that 19% of the vehicles are exceeding the limit of s kilometers per hour. Find the value of s, correct to the nearest integer. What we do, okay, it says 19% of the vehicles are exceeding the limit. What is exceeding the limit? We don't want to find the number here, 19%. We want to find the number that comes from here because it's exceeding 19%. For that, we don't calculate the 19% here, but rather try to calculate the remaining 19 here. This is the minimum value, and this is the maximum value. That is why we do this. We're trying to find the exceeding amount over here and calculate this remaining amount over here, 81%. What we do is go to menu, probability, distributions, and inverse normal. Oh, okay, it is asking for the area. Area, as I said, it's not going to be 19, which will be probably here, but it's going to be 81, which will calculate the amount over here. So I entered the values. The area is 81%. Mean, standard deviation. Okay, there you go. This is the, okay, mistake. We don't write 81 here because, as we remember, the probability under this bell curve is 1. So even the answers that were given here were given in form of 0.98, as in that's the probability, and you had to calculate the percentage yourself. So that's why we put 0.81. That's the probability, right? And 81 is the percentage. I entered the values here, pressed OK. There you go. This is what the question asked us to find: the S, the speed limit of S, exceeding speed limit of S. We found it. That's how you do normal distribution equations.